Right, good morning, good morning, good morning, good morning. I'm here to explain the counting principles. Um, so I have grouped the counting principles in so many different ways. So the first one that I've actually considered is, let's say if you've got a task that can be performed in a number of ways, as the first one, and the second one, the second task that is also going to be performed in another ways, that it becomes the N2. So if you have got such kind of questions, it means you are just going to multiply whatever you are going to have, the number of tasks performed, which are different. The tasks are different, so you must just multiply all of them if you're looking for the number of times or number of combinations that you can have from that. So for example, the first one there, I said n1 times n2. So it means if there are two task being performed, it means you're going to be say n1 times n2. If there are three, you're just going to multiply those groups 3 times. So just if you look at my example, I said suppose a menu offers 4 starters, 6 main course, and 3 dessert possibilities. How many meal combinations are possible if you choose exactly 1 starter, 1 main course, and 1 dessert? So whatever option that we are going to have there, so we are saying is the 3 tasks being performed here. So it means it's going to be n1 times n2 times n3. So it means you're going to say you're going to say you're going to draw lines like what I've done here. That becomes the first one. It's a 1, 2, 3. The 4 starters multiplied by 6 main course multiplying by 3 dessert possibilities. That gives you 72. So those are the number of combinations that you can have if you wish to take any starter and take any main course and take any dessert. Then let's go to the counting principle with the repetition. The counting principle with the repetition is the one actually which give us which bring us to powers, right? So I'll explain this using examples. So we are saying is actually on repetition. We are saying, let's say we've got the word counting, right? So if I am to arrange the first time and find the word count and actually make the word counting, we have counting, right? For the second time, I'll have ocnutgin. So if you compare the first combination and the second one, I just only mixed out the letters, but I've allowed repetition. So if I'm allowing repetition, that's when actually we are going to actually to which is going to bring us to power. Let's go to the example that I've given there. How many 5 number passwords are possible if each number must come from 0 up to 9? That means any letter may be used any number of times, right? Any letter may be used any number of times, right? So from 0 up to 9, how many numbers am I going to have? I'm going to have I'm going to have 1, 2, 3, 4, 5. So it means I want to form a 5 number password. So it means the first one I'm going to, from 0 up to 9, it means I'm going to have 0 up to 9. It means I'm going to have 10 numbers. That means on the first one I'm going to have 10 times. Again the second one, again the second option, I'm going to have 10 again. Third one again 10. The second fourth one again 10. The last one again I'm going to have 10. By the end of the day, instead of doing this, I could have just said I'm going to have 0 up to 9. Means they've got going to 10 possibilities to the power of 1, 2, 3, 4, 5. I want to make a 5 a number password, so it means it's going to be 5 to the power of 9, right? So by the end of the day, don't leave your answer like this. You have to punch it out. I think 10 to the power of 5, you punch on your calculator, it's 100,000. So we are going to have 100,000 times 5 number passwords from that, right? Now let's go to the second question. It says how many 4-letter words can be formed using the word meal? We've got the word meal here, and we want to form 4-letter words, right? The same principle. I've got 1, 2, 3, 4 letters, right? That are going to be 4 times. Second one again, I mix again. Maybe it was meal. Now it's now becomes maybe EMAL. I'm still repeating the same letters, so it means it's going to be repeating 4 times. That's the same as 4 to the power of 4. So what I'm saying is, from the word meal, what I'm trying to say is I've got the word meal for the first time, which is this one. Maybe the second one I'm going to have this. Maybe the next one, maybe I'm going to have this. So this is what I'm talking about, that actually maybe I'm going to have this one the first time, then second one maybe I'm going to have this, the third time I'm going to have this one. So it means I'm repeating the letters if you can see them, right? And again, this will also give us a difference when we're going to do actually combination and permutation later on. But for the meantime, actually, we just have to stop here. So 4 to the power of 4, 44 times 4, it's 16 times 4, 64 times 4, I think it's 256. So you can just punch to confirm your answer. And as I have said, that you need to leave your answer as the number of times. Don't leave it as a power. You need to multiply. Right, on this one, I have remember the first one on the second principle, we talked about counting principles with the repetition. So this time I want to show you some such kind of questions actually that doesn't allow a repetition, right? So it means on the first one, when we talk about repetition, it means actually we have allowed repetition. This time I'm not allowing repetition. So from this example, I have said how many 5 letters are possible if each letter must come from the alphabet? You may not use the same number more than once, right? So in this, we will also talk about that when we talk about order again. So in this case now, we are saying we're not allowing repetition. That means when I pick out a letter, so I want to form our main 5 letters from the alphabet. In the alphabet, I've got 26 letters. So it means I'm going to have I need to form 5 a letter from the alphabet. It means I'm going to have 1, 2, 3, 4, 5. Right? What is the possibility of me picking up actually forming the first one is going to be 26 times, right? So that way that I've picked out, if it was A, it means already out. How many numbers of times am I left with? I'm left with 25, right? The next one again, how many am I left with? I'm going to left with 24. I'm going to left with 23. I'm going to left with 22. Then you multiply all those numbers. 26 times 25 times 24 times 23 times 22, that will give you 7 8 9 3 6 0 0, right? So this is going to be your final answer. If you have got the alphabet and you want to form a 5-letter word from the alphabet, it means the number of times that are going to have there is going to be 26 times, because we are not allowing repetition. Is I've underlined that only one letter can be used only once. So if I use A, it's no longer used on actually secondly. That's it. If you use A, it's out. If you use B, it's out. So it means it's going to be 26 times 25 times 24 times 23 times 22, right? That will give you that give us this answer, right? Let's have a look at the other example again, where we are not allowing repetition. How many ways can the word counting be arranged if each letter must be used exactly only once? Which means we are not allowing repetition again actually on the same question, right? We've got the word counting, which is 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. Sorry, we have got 8 letters from the word counting. So we are saying now actually from that word, how many terms can we form? So it means we're going to have 1 2 3 4 5 6 7 8, right? So from this one, it means we are going to have the first one. If I use the word C, it means I'm going to have 8 times. If I use C is out, I'm going to use O. It means it's going to be 7 times. I use U 6 times. It's out. I'm not allowing repetition. N, sorry. 5. N is out. 5, 4, 3, 2, 1. Which is by the end of the day, it's just is 8 factorial. And I said do not leave your answer as a factorial. As I've said before, it means it's going to be 4 0 320. So it means if you take the word counting and you are finding the number of arrangements, it means you're going to have that number there, 40,320 times from that letter. Right, I'm going to talk about counting principles on restrictions. Counting principles on restrictions. That means I'll talk about individual numbers or individual words which are being restricted. So let's say we have got how many arrangement of the word words. We are using the word words are possible if you only have to start with the letter D, right? So from that, this one, how many words do we have there? We've got one. How many words do we have there? We've got 1, 2, 3, 4, 5 words from that. That means actually I've got from the first question, if you have to start with a D, and so it means I'm going to have 1, 2, 3, 4, 5. I'm going to have 5. That means from this one, if I'm going to have 5, it means if I start with a D, that means I've got only one chance of choosing a D, right? So the other ones will become so if I remove D there from the word from the words from this, it means I'm going to have 4 times, I'm going to have 3 times, 2 times, and once. Then if you multiply, it means 4 times 3 times 2 is going to be 24 times. So if you start with the letter D, from the word words, it means you are going to have 24 times number of ways. Then you have to start with the letter O and end with an R. So it means we have got we've got 5 words as from 5 letters, 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5. That means we want to start with an O and end with an R, right? How many number of times are we going to actually to have an O from there? It means it's going to be once. R, it means it's only going to be once. Then the other one, it means we're going to left with how many letters? 3, 2, 1. Then multiply the 3. That means your final answer, 3 times 2 times 1 is going to be 6. So it means you're going to have 6 number of times if you start with the word letter O and ends with an R. Right, you have to start with a consonant. Let's say you want to start with a consonant. You want to start with the consonant from our list from the way from word. We want to start with a consonant. So it means we have got from the word that we have got 1, 2, 3, 4, 5. So we want to start with the consonants. How many consonants are there in that one? So it means we've got 1, 2, 3, 4. Right. Please bear it in mind that this question is referring to the word words, not referring to the consonants actually in general. We're talking about from that word. How many consonants are there in that word? There are 4 consonants, right? There are 4 consonants. So it's from there. It means from there you would have 4, 3, 2, 1. If you multiply there, I think you have 4 times 4 factorial, which will gives you, I think, 96. I think it will give you 96. So it means you've got 4 consonants. You've got 4 consonants. Then from there, actually, you believe you're left with 4, 3, 2, 1. Then multiplying each other. Then it means you're going to have 4 and 4 factorial, which is going to be 96. So then let's go to number D. You have to start with, we have to start and ends with a consonant, right? Let's say, so here we've got 1, 2, 3, 4, 5, right? We're starting with, how many consonants can you start with? If you start with a consonant, it means they're going to have 4 consonants, right? Starting here, right? If you start with 1 here, and I've got 4 chances of getting that, how many chances am I going to have other consonants here? It means I'm going to have 3 times, I'm going to left with 3 consonants. If I choose 1 here, I'm going to have 3. Choose 1, 3, choose 1, 3, right? From there, it's 3, 2, 1. Then finally, this is like 4 factorial times 3. I think 5 factorial times 3. I think this answer will give you 72. Please confirm with your calculator if this is correct. So it means you're going to have, if you start with the consonant and end with the consonant, it means you're going to have 72 times. Then lastly, let's have counting principles restrictions on groupings, right? So it means we've got groups from such, but we are restricted because this question, it says a group of 12 people with 7 women and 5 are men. These 12 are seated on on a table. How many possible arrangements are they allowed to sit together, right? So from here, this one, please listen carefully. We've got 7 women and we've got 5 men. So we need to allow women only to sit together. So it means we don't allow any men to be next to a woman, right? Okay. So from here we are saying that from here we are saying we've got from here we are saying we've got 7 women, isn't it? So 1, 2, 3, 4, 5, 6, 7, right? We've got 7 women. That means 7, 6, 5, 4, 3, 2, 1, right? That's the first group, and no man is allowed to sit next to it. So it means we're going to have this group of women sitting together. Then we've got another group of men also sitting together with theirs, which is 1, 2, 3, 4, 5. So a 5, 4, 3, 2, 1, right? So this is what we are going to have. So this is the first group that we are going to have. So if I consider this, or let me not put this one in a group, it means I've got them separately, right? So if let me put it like this. So it means if I consider this, that means this is a group of women sitting next to each other, and then you've got men separately, right? So how many groups are we going to have? So from the first one, I'm going to have 7 factorial times, right? If I'm to consider groups, it means I'm going to have, this is a group that is 1, 2, 3. I'm going to have groups 1. This is a group 1, which is sitting next to each other. Then I've got 2, 3, 4, 5, 6. So times 6 factorial, right? So finally, if you punch 7 factorial times 6 factorial, I think you get 3, 6, 2, 8, 8, 0, 0. So let me come again actually on this question. This question is a little bit tricky in the sense that we are saying we want women to sit together, and the women are 7, so it means that becomes 7 factorial, and the men will sit randomly. Maybe we have 2 on this side and the other 3 on this side, or 3 on this side and 2 on this side, or 1 on this side, other 4 on this side. That does not matter. But what we are saying is from there, 7 factorial, it means I'm going to have from there I'm going to have the first group, which is this one, first group, then 2, 3, 4, 5, 6. So it means I'm going to have 6 factorial. So it means I'm going to multiply the 2 and get that answer. If all women sit together, we're going to have that number of combinations, right? Another same question. Let's say all women sit together and all men sit together, right? So in this way, we are saying we've got a group with all women. 1, 2, 3, 4, 5, 6, 7. Then we've got also a group of men. So this is women. This is men. Which is 1, 2, 3, 4, 5. There are 5 of them. So it means we've got 7, 6, 5, 4, 3, 2, 1. Sorry, I jumped. So that means this is 7 factorial, right? Then here we've got 5, 4, 3, 2, 1. That means this is 5 factorial. So I can have a group of women sitting like this, and also have men sit like this, right? Or I can interchange again. So this one comes here, and the woman goes to the other side. So it means we've got 2 groups and 7 factorial times 5 factorial, right? I think we're together there. So what I'm saying is the first group, I can have women sitting together first there. Then nextly, I can also have start with the men, it ends with a woman but sitting together. That means it's going to be 5 factorial times 7 factorial. Then times 2, we can have 2 possibilities. So that means my answer from there, it's going to be 5 factorial times 7 factorial times 2 possibilities. So by the end of the day, I think you get something like this. These are the number of possibilities that we are going to have from 5 women, 5 men sitting together, and 7 women sitting together. These are the notes that I've prepared for counting principles. So please have a look at it and understand each. Thank you.